Good morning, everybody. Welcome. I hope you can all hear me. Welcome to this first ever Water Test Network webinar. My name is Stefan Bersma. I work for the Water Alliance, which is the network organization for Dutch water technology companies. And we are one of the partners in the Water Test Network project and also your host for today. So what I will do is I will introduce the speakers to you. But before we go to the webinar, I would like to make some general remarks about the webinar and the platform we are using. So firstly, the webinar will take approximately 1 hour and a quarter. As you can also see, we are recording the webinar. So if you want to look at the presentations after the webinar, this is a possibility. And we will also send the presentations to you. Furthermore, you can also see that you are muted and that your cameras are turned off. We also would like to say to you that please keep them off, so only the presenters will turn on their cameras and will speak. That does not mean we don't want you to actively be involved in this webinar. We really would like you to be. So therefore, if you have questions during the webinar, you can ask them in the chat function. You can find the chat function at the bottom of your screen. You now already see that some people said something in the chat function. There is the place to ask your questions. And at the end of the webinar, we have a short Q&A. And there we will try to answer your questions. So again, if you have questions about the presentations, please post them in the chat function. Then the program of today, if everything, yes. Here you can see the program of today's webinar. So after my short introduction, we have Ruth McNeil from Scottish Water, who will tell us everything about the Water Test Network project, what we are doing, and what kind of services we provide for SMEs. Then we have a special part where 4 different companies will tell their experiences with the Water Test Network. And what is good to mention here is that these are short presentations, and after these presentations we have time for 1 or 2 questions. So during the presentation of the companies, please also ask your questions in the chat function, and then we have time to answer one or two of them after these presentations. And then the last presenter will be Charlotte Boucard from Flaqua, who will tell something about the innovation support vouchers we provide for SMEs and the application process. And after that, as mentioned, we have a Q&A where the presenters will turn on their cameras and you can ask your questions, or you already did that in the chat function and we can answer them. So that's the introduction. Then please, let's move on to the first presenter, which will be Ruth McNeil from Scottish Water. Enjoy.
Thanks, Stefan. I'll just get the presentation started. Okay, so what is the Water Test Network? We are a transnational collaboration which aims to create a network of testing facilities across Northwest Europe. Our aim is to address key sector challenges faced in the water sector by supporting SMEs. By supporting SMEs to develop, test and verify innovations and help accelerate the time to market. We were allocated funding through the Interreg Northwest Europe programme through their innovation thematic priority. The programme receives ERDF funding up to 60% for our €6 million project. We have a total of 7 project partners, 5 sub-partners and 5 associated partners, all actively contribute to our project. The network provides access to 14 operational testing facilities across Northwest Europe, with access to a range of water types and applications. We have 1 in France, 1 in Germany, 2 in Belgium, 7 in the Netherlands, and 3 in Scotland. These facilities are accessible to SMEs across Europe with a focus on those countries in Northwest Europe. As I said, the testing network enables testing on a range of water types, including municipal waste, sludge, tap water, raw water, hospital wastewater, and many others. I'll give a little bit more detail now on what services can be accessed at each of our testing facilities. So at our testing facility in Germany, our testing facility in France, at Prime, it provides experimental testing on a variety of scales for drinking water, untreated groundwater, which can be extracted on site, and you can also have access to other wastewaters, which can be brought on site as requested. Sorry, the slides do keep moving on, please bear with me. In Germany, the Water Technology Centre, operated by TZW, provides access to drinking water from the local networks available after various treatments, including flocculation sand filtration, membrane filtration, including reverse osmosis and microfiltration, and disinfection techniques such as chlorination and UV. Sorry, technology seems to not be working for me today. Our partners in Belgium, Vito, partners with Ghent University on the VeggieTech facility. This is a university research and expertise centre for the processing of vegetables and potatoes, and it can provide testing facilities for surface water, phreatic groundwater, rainwater, tap water, and vegetable processing process water and its wastewater. Vito also partner with the Water Group at De Blancart, which is a pilot installation for research into an alternative approach to conventional surface water treatment. The testing facility is available for SMEs to test their technology for treating surface water into drinking water. It also allows for testing techniques for treating wastewater from the ion exchange process. Sorry, someone seems to have taken over the control of the presentation.
We will try to help you, Ruth, that the slides will not go automatically.
Those on the webinar who have experience of me know that me and technology often don't get on, so it's no surprise that this has happened with my slides. So please do bear with us.
Ruth, this is Farah from Water Alliance here. What we can do is that I'll be showing the presentation and that you just give me the option of giving you the next slide. So whenever you say next slide, I will make sure you will see the next slide. Because technology apparently isn't working. So we will do our best to help assist you on that. So what slide do you want me to show?
Could you go on to I think it'll be your slide number 8.
Slide number 8. Okay, let's go then. Which is this one, right?
2 more on. Yeah, perfect.
Great.
Okay, so I'll just recap that. So our partner Vito in Belgium sorry, go back one again. Yeah, thank you. They partner with Ghent University on a facility called Vegetech. So this is a new facility that's being built. It's a university research and expertise centre, and it's all about processing for vegetables and potatoes. You can access various types of water at this facility: surface water, phreatic groundwater, rainwater, tap water, as well as the vegetable processing, processed water and its wastewater. Vito also have a second test facility. They're partnered with the Water Group at de Blankhart, and this testing facility is a pilot installation which for the research into alternative approach to conventional surface water treatment. So at this facility, SMEs are able to test technologies that look at treating surface water into drinking water, or testing techniques for treating wastewater from the ion exchange process. If you go into the next slide, please, Farah. In the Netherlands, there are 7 testing facilities. 6 of these are through our partners CW and the Water Alliance, and they provide various access to various types of water. So you can have hospital wastewater, desalination and blue energy, municipal wastewater treatment technologies. You can experiment with sensor and data measuring applications, biological treatment for industrial wastewater, as well as water flows on a dairy farm. Our other facility is the Wastewater Treatment Centre in Apeldoorn, and here you can access, again, various types of water, such as municipal wastewater, municipal and industrial sludges, biogas, struvite and tap water. If you go on to the next slide. Our last 3 testing facilities are in Scotland. The first of which is the James Hutton Limited, which provides laboratory verification services, and they handle samples from outside of the facility. It includes inorganic and organic pollutants analysis, which is mostly accredited to ISO 17025. Their scientific team has many years of expertise analysing the environmental waters and private water supply. And then finally, we have Scottish Waters Development Centres. There's 2 testing facilities here. One is the Wastewater Development Centre at Bowness. Here you can access various types of municipal wastewater, raw unscreened, screened, secondary sewage, activated sludge, as well as final effluent. And you can also access industrial wastewater of various types. Again, this would be available upon request. The Water Development Centre in Gorthlick, thank you, Cara. The Water Development Centre in Gorthlick near Inverness provides access to raw water connections, filtered water and borehole raw water. So as you can see, there are a vast number of water types that can be accessed, and a lot of facilities for testing your technologies. If you go on to the next slide, please. The aim of our project is to speed up market uptake of innovative water technology. And we do this by making it easier for SMEs to test and verify their innovations, to overcome that reluctance there can be within the water sector of unproven technologies. Our transnational network enhances innovation opportunities and accelerates the time to market. We enable SMEs in fine-tuning and testing technologies in a real setting, so they can develop technologies that are market-ready and linked to key sector needs. By the 6th of December 2021, which is when the project is due to finish, we hope to have supported at least 120 SMEs, with 90 technologies tested through our testing facilities. It is our hope that we could get upwards of 30 technologies support to accelerate onto market. And by the end of the project lifecycle, we hope to have built a sustainable business model so SMEs can continue to access these testing facilities as we've set up under the project. If you go on to the next slide, please. So we provide fully funded support packages in what we call innovation support vouchers. So these are tailored to the needs of the SMEs, and we can provide support of up to €50,000 of total in-kind support. We provide 2 types of innovation support vouchers, the first of which gives you access to a testing facility. So this could be from a couple of days in a lab to several weeks in a full-scale water plant. Really is tailored to the needs of the SME. Our other innovation support voucher is around support with verification and validation, and this is to assist with market entry. It can include help for SMEs to get ISO or similar verification of their product. Next slide, please. So where are we at the moment? So to date, the Water Test Network has received 80 applications. We've supported 57 applications through the application process into stage 2 submissions, and this often includes help in designing their test plans for going to one of the testing facilities. We've had 12 technologies so far approved for support, and 4 of the trials have actually now completed through the project. If you go into the next slide, it'll just give you an idea of the range of countries where our applications have come from. So at the moment, we have a good spread across Europe. There are some hotspots, as it were. So we've had 1 in Austria, 3 in Belgium, 1 in Denmark and 1 in Finland, 7 in France and 11 in Germany, 23 in the Netherlands, 1 in Sweden and 32 in the UK. And we keep getting more applications week on week. So hopefully we can maintain this spread of applications across Europe. It really helps that transnational movement of technologies, which is great. If you move on to the next slide, please. So we have various technologies that come through the Water Test Network. And these can include phosphorus removal from primary settled effluent with the use of microalgae, using a novel biocatalyst to intensify the biological process in order to remove ammonia and TBOD. We have had treatment systems for recycling water for greenhouses, and different screening technologies that don't need wash water or brushes. And we've also had thickening technologies focusing on sludge thickening. And these technologies specifically have come to us through our innovation challenge. Now, our first innovation challenge was released last year, and we've got another one live at the moment. And my colleague Charlotte will talk a little bit more about that later on in the webinar. If you go on to the next slide. So now's the opportunity for you to hear from a few of the SMEs who have come through the Water Test Network and hear a little bit about their experience with us and about their technologies as well. So I will go on mute and hand over to them. Thanks, Stefan.
Yes, thank you, Ruth. Thank you for your presentation, and apologies to all for the technical issues. We're trying to solve it in this way, what we just did. As mentioned before, if you have questions for Ruth, please ask them in the chat function, and then we can come back to these questions at the end of the presentation. So please use the chat function for this. Then now we have a part where 4 different companies will tell their experiences with the Water Test Network. And first up is Dr. Michael Kuhn from the German company Kuhn. Again, Michael, also for you, please, if you want to go to the next slide, please mention it to Farah, and then she will click on to the next slide. So the floor is yours. Thank you.
Thank you, Stefan. Thank you very much. Hello to all participants. I'm really happy that you joined our webinar. I want to start with a short introduction of Kuhn. We are a German manufacturer of high quality machines for the mechanical treatment of wastewater in wastewater treatment plants. We are a family run enterprise with more than 90 years of experience and more than 160 employees. Our product portfolio includes all types and sizes of Archimedean screw pumps, screens, screening treatment, pre-treatment, conveyors, compact lines, and heat exchangers for wastewater. We are specialists there. We offer turnkey products, including maintenance and repair services, everything from a single source. It's Kuhn. We have extensive expert knowledge based on decades of experience in manufacturing of wastewater engineering systems and the installation of several thousands of machines. What is very special for Kuhn is that we have both mechanical and electrical engineering services, so we can give the whole application to you as a customer. And our machines provide clean water and clean energy in more than 40 countries all around the globe. Next slide, please. Okay, so what we are doing is we are manufacturing screens for municipal wastewater treatment plants. These machines do things which are not too nice to look at. The left top corner, you see screenings. This is a picture I took in Johannesburg, South Africa. You see all kinds of debris are coming with the wastewater, and this makes it difficult to clean the machines and to keep the plant running. So therefore, we have to protect the machines. And on the left lower corner, you see a picture from Sara Gabaron from Spain, where you see MBRs, which are really have a thick layer of screenings, which is giving the MBR a very low flux, and this is not good. Therefore, we have machines like in the top right corner who are protecting the whole wastewater treatment plant for all the processes and machines downstream of the plant. We have these machines. We are spread these machines all over the world, but the problem is in UK we have special regulations. I just have the MET 4170 as an example, which gives us hard access to the UK market. Therefore, we had to have an idea how we can provide our machines for the UK market. And first of all, we had a new innovation, a new idea for a machine. And this idea was sounds quite good, but we have to prove it in the UK. And this is the problem, because how do you organize a test facility in the UK where you have the support of the operators and the support of the water authority, so that you really can test your products well? Because we are sitting in Germany and we have to go to this plant and test it, but there, as you know, we have to run it for a longer time, and so therefore we need support from the operators locally. So I finally came to know about water test network, and this was quite good. Because I learned that this could solve my problems. And next slide, please. So I went to the German part and talked to them, and they said, okay, there is no problem. You have to apply for stage 1, which we did. And you see the left paper that we had the application form for stage 1. It was a 1 or 2 page, so not too difficult to fill in, and and we got help from the German side, so this was quite good. And finally we were approved for stage 1. This brought us to stage 2, which is a little bit more of paperwork, and we are already handed over to Scottish Water, and we got a great help there how to apply for this stage 2, and we had quite some mails going back and forth, because we had to make sure that our application has the right attitude and the right words in it, so that it could be approved. It took some work, and this is good, because it's not just fill out a one-pager and you get the support. No, you have to work on it. You have to look. You have to really make sure that the people know what you are looking for, what you do want to hear, what you want to learn from this task. And finally, we got the letter of approval for stage 2, which made us really happy. And now on the lower right side, you see a picture of Bonus municipal wastewater treatment plant. By the way, I visited it in February, right before Corona pandemic started, and you see a good plant and a great view of the Scottish Highlands. which is very nice. By that time, we had still some snow there. So I'm looking forward once the plant is open again, once we are allowed to travel, once we can travel safely, that we will install our machine and hope that we can prove that this machine fulfills all the requirements of the UK, and then can start selling the machine in the UK. Thank you very much.
Thank you, Michael, for your presentation. And at the moment, I don't see a question for you. So I would say let's go to the next presenter. And if there are any questions for Dr. Michael Kuhn about this presentation, then please, again, ask them in the chat function, and we can come back to that later in the Q&A session. So I would say let's go to the second company, IPM, from Denmark, and the presenter is Jafar Nouri. So Jafar, please, the floor is yours.
Hello everyone, nice to meet you all. I'm here to present IPM, a company from Denmark. We started back in 2014. Our main business and the core, we are R&D developing sensors that can measure chemicals directly in water. We mainly focus on measuring pesticides and fertilizer directly in water without any need for sample pre-treatment. If we go to the next slide, please. So most of us are aware that actually monitoring the water quality, it's a very tiresome process. It costs time and money. You need to go and do field sampling, collect the samples, send it to the laboratory, wait for results, and then you are getting only a snapshot of the results. You are not up to date with what's going on in the field. This is the process that we would like to replace with our new innovative device. So if we go to the next slide, please. We are providing, we are providing a complete system that can be installed and left in the field. So if you look, we provide a hardware and a software package. The hardware package consists of two main components, an IPM torpedo, and then the communication system, which is provided by our partner from Norway, Kautokeino. Once you install this system in the field, then you can access through a web server with special login, and then you can continuously measure your like the specific contaminants that you are interested in. Normally, you will invest in this in one time and the main torpedo, and then if you, let's say, you get some chemicals and 2 years from now you get a different situation, or like different chemicals start to appear, then you can just modify your sensor cartridge. Of course, you cannot see the animation today in the presentation, I'm sorry about that. But then with 2 screws, you can remove this old sensor cartridge, put a new one in, and you are good in business. So far, we have been in a prototyping stage. We didn't validate the results with the clients. We didn't hand it over to any test facility, and that's where Water Test Network actually comes in very handy and very helpful, and thanks to them. We also went through this application process, the first stage and the second stage, and we are actually looking forward to start testing with them, hopefully late this year, where we'll hand in one torpedo to be measured. And like what we would like to get out of this program is a story and a validation results, so we can go to the customers and to the clients. As you maybe all of you know, the water market is very conservative, so we need to show that actually we can deliver what we are promising, and that one of the things that will come out from this program is actually a validation test that we can show to the clients. With that, I will say thank you, and if you have any questions, please feel free to ask. Yes. To you, Stefan.
Yes, Jafar, thank you very much for your short but clear pitch. Again, there are no questions yet for you at the moment, but there is actually. The question is, do you also measure biofilm contamination?
Unfortunately, no. We focus mainly on chemical contaminants. not bacteria or biofilm. Sorry.
Okay, thank you. Well, and also thank you for the questions asked, because this is very good that we have a little bit of a discussion. So if you have other questions for Jafar, please ask them, and then we can come back to them at the end of the webinar. So Jafar, thank you for now, and we will go to the third presentations of the companies, and that will be by the company called Microvi UK, and the presenter will be AJ Nair. So AJ, please tell us your story.
Thank you, Stefan. Hi, good morning, everybody. I hope you can all hear me and see me. Thank you very much for the opportunity, not just for this particular presentation, but also for the time that we spent with the Water Test Network for the last 18 months or so. Microvi is a biological organization. We look at developing microbiology to be more efficient and more effective in current water and wastewater treatment applications. Although we do also work in different bio organizations such as biofuels and biopharmaceuticals. Traditionally, the water sector and the wastewater sector has used a paradigm of biological treatment that's about 100 years old. And that's based upon the desire to grow and facilitate structures in order for microorganisms to be able to treat pollutants within that wastewater. The paradigm has always been based upon growing vast quantities of these organisms and trying to control their population dynamics using very crude measures. These include the type of process, whether it's fixed film or suspended growth, the type of bioreactor that it's involved in, and the conditions such as aerobic, anoxic, or anaerobic, or other more refined control systems such as pH, dissolved oxygen, or solids retention time. Microvi, as an organization, and we started in 2008, took a different approach. We actually said, let's look at the microenvironment, the small environment around a microorganism, to understand how those immediate conditions can change the behavior of that particular organism in order to make it more efficient. So we went about and we developed what we call micro-niche engineering, which is a biomimicry type process where we mimic the natural habitats of organisms in order to create them within a controlled environment that we can deploy at vast quantities into water and wastewater treatment. We do that by a combination of material science to understand the unique structures, the unique surface chemistry and the charges that are required for a particular organism. We also then look and seek different organisms to ones that you typically find in water and wastewater, all naturally occurring, but ones that we feel may be more efficient or more effective, but normally don't survive in conventional treatment processes because they're outcompeted by faster growing organisms. Not necessarily better ones, but ones that will grow faster. So as a result of these two breakthroughs, breakthrough one being the material science and breakthrough two being the ability to select and retain microorganisms, we create a biocatalyst. That allows us to move to a single species of organism that can be deployed at very, very high concentrations in small 5 millimeter size spheres that can be put into a biological reactor that can treat either water or wastewater. But by doing this approach, what we find is we can intensify the treatment capacity by over 300 or 400%, meaning that we can shrink the size of reactors and therefore reduce the capital cost. But also we avoid a number of high OPEX type reactions occurring that would lead to increased energy consumption or increased chemical consumption. Also, because the organisms are retained within this biocatalyst, we're able to move away from load dependency, which means we can apply the treatment process in any different configuration, moving beyond the traditional approach that we have today. Also, as a consequence of this approach, what we find is we dynamically change the behavior of organisms. So they move away from wanting to generate biosolids and produce a surplus product to those that just focus on cell maintenance and respiration, which means that as a consequence of biological treatment, we don't actually produce any excess biosolids. That in itself leads to a reduction in costs associated with the overall treatment system. It also means that the flexibility of the system can be applied anywhere. So as a consequence, we have a number of key benefits. We have a reduced footprint. I mentioned zero biological solids production, a reduced energy consumption of between 30 and 40%. At the same time, you can also increase biogas production from existing processes. The system itself is very low maintenance because the complexity is inside the biocatalyst. And also, as a consequence, we feel that it's a very fit and forget type technology. You know, it's applicable both to water and to wastewater treatment, and it covers everything from BOD, COD, right through to priority substances, phosphorus and nitrogen. I'm going to flick onto the next slide for me. So one of the questions that we were asked is, what are the benefits of the water test network? And outside the sort of financial benefits, as in the support that you get in terms of the innovation vouchers, one of the key things for us is that we're able to test and develop our technology in a safe and controlled environment. That means that we don't necessarily have to be on site ourselves. I live or I'm based something like 230 miles from the test center in Bo'ness. I only have to visit that facility on occasion because we actually have the availability of operators and maintenance crews that can help us run the test. We have remote access, but we also have constant dialogue with the operators. And that way that we can make sure that our facilities run constantly and reliably, meaning that the results that we get are viewed with a high degree of credibility. The second aspect of the benefits of the water test network is the exposure that we get. If you imagine a facility where there is a lot of interest from other organizations and there are other tests going on there, you actually get a lot of clients and customers visiting that particular site, which means that whilst they may not be visiting your technology in the first instance, because you're on site, it piques their interests and you're able to get additional interaction with customers that you may not have previously had interactions with. So that level of exposure through the tours and also some of the organized collaborations that the Water Test Network put on, such as webinars, and also the facilities that you have on site to be able to host meetings and do tours is just exceptional. That has been an absolutely excellent marketing platform for ourselves, and sort of taken not just the credibility of the testing forward, but also the exposure of the technology to the customer. So, if there's any questions.
Yes, there are actually two questions for you, AJ. The first one is, did you test your ID in municipal wastewater also?
The answer to that one is yes. The trial that we did at Bo'ness was purely based on wastewater, on municipal, testing both primary settled and also secondary treated.
Okay, and the second question is, can you avoid the negative effects of anaerobic bacteria, change their behavior? Question mark.
Yeah, we have actually tested anaerobic bacteria inside the biocatalyst as well as aerobic bacteria, and we have had some success with that, but it's a work in progress at the moment, that particular application.
Okay, well, thank you, AJ, also for answering the questions. Then let's continue with the last presentation of the 4 companies, which will be presented by Martin Ryan, the CEO of Farum Biotech. Martin, please continue.
Hello, everyone. My name is Martin. I'm the CEO and founder of Farum. We work with enzyme-based, so it's, I guess, a nice evolution of the previous presentation that we focus on the kind of biomolecules that are usually the part responsible for degrading different kind of pollutants. Our company focuses a lot on difficult organic micropollutants, trying to identify and apply different kind of enzymes toward very difficult organic micropollutants that usually are missed at the throughout the wastewater treatment plants. So pharmaceuticals, for example, is a big one, and that's actually where the name comes from. Farum actually stands for pharmaceutical removal. Today we work with many more different kind of pollutants, with pesticides, herbicides, and plastic derivatives, and many of these kind of pollutants as well. But it gives you an idea on the scope of what we're doing. Next slide, please. So it's a little bit unique approach. Not too many are working on the enzyme-based kind of technology. Most of it is still in the R&D phase, but the technology is mature enough to take the step into the market, and we are one of the first ones to try to do this. The thing around enzyme application is that the functionality of enzymes can be very, very different, so you can get a very different kind of chemical reactions. Which opens up actually to a very diverse kind of application of the system. You can target specific pollutants, or you can apply many different kinds of enzymes and get a very wide range of approach. And of course, there are ups and downs. If you have a wide, you can get a decent high removal. On a broad range, if you make more specific, you can very high removal on a few substances, for example. We're working both in industrial and municipal wastewater, so we have a few applications on the industrial side, and we are working, for example, together with Interreg on the municipal wastewater side. And the flexibility in the entire system makes it it's a good way of trying to look at efficiency, targets, cost, and many of different kind of adjustments that can fit different kind of applications. The benefit of enzyme-based technology is that it's actually very cheap. We use enzymes today in many different kind of industrial applications and used a lot in society. I don't think anyone can go home and see a detergent for their washing machine or the something like that without having enzymes in it. You see it in the back end. So there are an established industry for very large production of this, and you can get down the cost a lot. And much of our IP and so on comes from actually the building the application itself. So we have found a very kind of a cheap way of producing material, and a cheap way of binding the enzymes onto the material, and a cheap way of producing the specific enzymes that we want to have, and makes it a very kind of simple application. So to give you a picture of it, is that it's more like a sand filtration. It has about the same kind of limitation when it comes to SUSP and water quality and so on. So wherever you can put in a sand filtration, you could also put in this kind of application, and but with the added effect that, of course, it targets these OMPs, organic micropollutants, and remove them at a high degree. We mostly don't say that we are much better than, say, ozone and activated carbon. That usually are the two technologies mostly talked about on this market, but we have about the same kind of removal, but the simplicity of the system makes it very cheap to install, so the capex cost is always minimal. We even try to give it for free to the municipals, but that was a difficult road. They didn't really understand the concept with procurements and so on. And the OPEX is comparable to ozone-based solutions. So it's the plan is to have a very low hurdle to get it in. And since it is a hand filtration-based kind of technology, the needed infrastructure around it is also very simple. You pretty much only need to have water passing through the mass, and the enzymes will take care of the rest. And when it comes to the hazardous imprint of it, it has the same classification as the sand filtration, so it doesn't add any hazardous challenges to the infrastructure. That is a little bit downside with other type of technologies. So it's a summary of how we see the technology and the benefits around it. Next slide, please. So we have a few demonstration sites. We actually have a Horizon 2020 project around it. So this is a little bit different approach into the Interreg, I would say. We have an application. We have an installation at the Netherlands site in Apeldoorn, which is we came to Netherlands with the funding from the Horizon 2020, but then got approached by Apeldoorn, who is part of the Interreg community, and approached us and said that we have this and we would love to introduce your technology into the project same time. So what we really get benefit from the Interreg is that it opens up a much larger scale and imprint of what we can do on the site. So we have so what we get from this is really opening up new possibilities and capacity of scaling everything up. If we only did it under Horizon 2020, we probably need to pay a lot more for the infrastructure and the changes needed to do on place and many other of the things around it. So in that sense, we get a much more value added to our project demonstration sites that we want to use for the technology. And just to here you can see actually this is the installation actually on the Swedish site, but it's similar in the Netherlands, and the simplicity of it. So this is actually a retrofitted sand filtration. The one in Netherlands will have a little bit more customized to our technology. So it's very simple to just add into current infrastructure or similar kind of things that are already applied on wastewater treatment plants, and something we think is part of the simplicity of the entire application. And that's it. Thank you.
Martin, also for you, thank you very much for your presentation.
Yep.
We have actually two questions for you. The first one is, do we need additional energy? In example, pumps?
Yeah. No, actually not. Or what you need is you have a hydraulic loss of about 40 centimeters over the entire system, so it's a very low pressure drop. And if you have that fall height in already on site, possible on site, then of course you don't need any pumps at all. But if you need it, it's very difficult. So mostly we're actually looking into digging it a little bit into the ground on the sites that we are presenting it for, and it can run on. Or usually you have that flow, that pressure actually already existing in the outgoing flow. So it's possible to have it can be completely energy independent solution. So, but it's a little bit site specific. So there's a small pressure drop, but most sites will probably be able to do it without any pumps.
Okay, thank you. And the second question is from Garrett Caves. Can you treat MCPA, weed killer, in drinking water at flows up to 50 mLD?
Yeah, we are. It's the pesticide side is something we have. It's one of the last areas we've been starting to look into. So far we haven't really had a problem of designing this to work to different kind of pollutants. So we already have a lot of good results on benzoids and these kind of pollutants. I'm not sure specifically if we have looked at the MCPA type yet, but I need to recheck that, and I'm more than happy to open up give you some information specifically if you're interested. I also want to mention around the Netherlands site. I forgot to bring it up, but it's we are also building a bigger infrastructure around the project itself. So KWR is part of it, for example. So they took part of setting up a lot of the work, and also in the presentation see that we will also working together with Stova. So Stova will actually take over the sites after the Horizon 2020 project runs to its end. So it's we think it's exciting because it gives a lot of organization insight into what we're doing, and a lot of people that can have a view on the technology, and hopefully all are satisfied of it, of course, in the end also, but which we are sure about. So, but it gives a bigger impact on things, so that's very nice.
Okay, well, thank you for your answers, Martin, and your presentation.
Thank you.
And I also saw in the chat function that there was a presentation. Okay, well, very nice stories, but how can we apply? And that will be the topic for the next presentation. Charlotte Boucard will tell us more about the innovation support vouchers and especially the application process. So Charlotte, please take it away.
Yeah, okay, thank you. So if you are a technology provider and you have new innovation which you would like to get on the market, but you still need to do some further testing, you need to fine-tune your technology, then we welcome you to come to one of our test sites. But to get access to the test sites, you first need to apply for innovation support vouchers. So once you have this voucher, you get access to the test site, which means that there will be an operator who will help you with the tests. He will take samples, analysis will be done, and the test, the voucher includes all the costs associated with this, the staff, the analysis cost, the electricity, the water that needs to be provided. What we ask you to bring yourself is your technology. So if it's a sensor or membranes or a pilot equipment, you need to bring it to the test site and you need to cover for the logistics which are associated with it to get it on the spot. And if you would like to stay around and to be there when the test is being set up, then we ask you to pay yourself for your travel and accommodation. And the support that we offer, a kind of in-kind support, can go up to a maximum of 50,000 euros. Next slide, please. So who can apply? The innovation vouchers are open for small and medium enterprises from Northwest Europe. And the definition of SME is that it is an organization which has no more than 250 employees and a turnover of maximum 50 million euros. Next slide, please. Okay, if you want to apply, you need to follow a 3-step procedure. And the first step is that you need to contact your innovation chaser. Next slides. So we have in total 8 innovation chasers in the water test network, and this innovation chaser is your first point of contact, and he or she will help you throughout the entire application process. Next, please. Okay, so I am the innovation chaser for Belgium. We have Christophe for France, Beate for Germany, Liam for Ireland. Next, please. Then we have Jordi and Pieter Jan for the Netherlands, Roger for Scotland, and Ruth for the entire UK. So you can call them, you can send them an email. You can also find these contact details on the website. And please, if you have an idea, contact them, tell them about your product, and they will help you and judge if you are suitable to go for an application for the innovation vouchers. So please, this is your first step to take. Okay, next slide. Okay, once you have been in contact with the innovation chaser and they think your innovation is suitable to be tested, you can go for a stage 1 application. Next, please. This actually consists of 2 parts. First of all, we ask you to complete and to sign an SME de minimis declaration form. So in that form, you declare that you are an SME and that you are in rule with the de minimis regulation. And the de minimis regulation actually we need to take into account this regulation in this project, and it means that we can only support SMEs which have not received more than 200,000 euros of support in the past 3 years. So if you are not too well informed about de minimis, again, your innovation chaser will help you with this, because certain research projects are not regarded as de minimis support. For example, the former speaker mentioned that he is involved in a Horizon 2020 project. For example, these kind of projects are not regarded as de minimis support. So if you need help for this, we will help you to find out which support you have received already. Okay, together with that declaration, you also need to submit a stage 1 application form, which is a very simple 2-pager document in which we ask you to provide your contact details, and you also need to describe in brief your innovation and explain which support you are looking for to have your product further validated. These documents are all on our website, and I have inserted a link for you to find it. Okay, please go to the next slide. Yes, so once you have submitted your stage 1 application, you will get an approval letter if everything is okay, and you can proceed to stage 2. Yes, next slide, please. And stage 2 is a bit more elaborated. There we ask you to describe the current TRL level of your technology. So TRL stands for technology readiness level. And we actually allow technologies which are at TRL level 4 up to TRL level 8. So your technology should be already validated in the lab, and it should be ready to go for bigger testing, so at larger scale, larger volumes of water, etc. We also ask you to describe the tests that you want to do. You can do this together with the Innovation Chaser and with the test sites. So we really work together with you to come up with a sound test which is suitable to validate your products. We also want you to describe your target industry, the risks that might be associated with your technology and with the tests, and also the economic impact. If we would give you access to the test site, what would it mean for you as a company? Would it help you to increase your turnover? Would you be able to hire new employees? Would you be able to reach new markets? And we also ask you to describe the wider impact. What would your innovation improve in terms of the society and the environment? And this stage 2 application is about a 10-page document. It of course all depends on how detailed you are in your descriptions. Again, I added the link on which you can find these stage 2 documents if you want to work on this. Okay, next slide, please. Okay, what is now the timing? The application can be submitted at any time between the start of the project and the current deadline is the 1st of August 2021. Now, due to COVID, we are facing some delay, and we are discussing a potential project extension with the partners. So it is not decided yet if we will go for a project extension and if we will get it from Interreg, but it might be that the deadline of August will be postponed, but that you will hear then when the time is there. Now, the time to evaluate your proposals, I think it goes quite fast. So stage 1 evaluation can be done within 1 week. And actually, if everything is okay, it can be on the same day if the project partners have time for it. The evaluation of stage 2 takes more or less 1 month. It can be a bit less, it can be also a bit more. It all depends on the availability of the people to judge the proposals. So we are with 3 independent people who evaluate your proposals. So all these 3 persons needs to be available, and it depends on the amount of applications that we have received. But normally we can do it on a quite let's say, speedy way. Okay, thank you. Next slide, please. So that was a bit my explanation about the application process. Besides that, we also have problem solution challenges within the project. This is something different. Here we turn the situation around. It's not the technology provider who wants to test their technology. We launch a problem and we are looking for technology providers to come and to showcase their solution. And we have the goal to launch 5 of these, what we call innovation challenges over the project lifetime. And at this stage, we are at challenge number 3. Now, the problem that we launch is actually a problem which has been experienced by water users. So it's a practical problem that is faced today. It can be a problem typical for a drinking water company, for a wastewater treatment company, a problem of a large industry. And we invite SMEs to come and to demonstrate their solution. So in this specific challenge, you will really meet the buyers, because we really bring together the problem owners and the technology providers. And we also encourage collaboration with academia if this is already the case. Okay, next slide, please. So, as Ruth already told, the current challenge is now open, and we invite technologies which are suitable for the removal of PFAS, or perfluorinated alkylated substances. So the innovation challenge, it's a competition. It's we invite everybody, but there can only be one winner. And if you are the winner, you get access to the test site. We will organize webinars with problem owners so that you can really meet the potential buyers. And we also give you the opportunity to be present at an international water fair where you can take a booth to demonstrate your technology and to meet potential customers. So if you are interested to take part in this challenge, we ask you to run through the same application process as I explained before. So you need to submit a stage 1 and stage 2 application, and you need to submit a stage 2 application by the 1st of September this year. And all details of the challenge can also be found on the web link that is shown there. Okay, next slide. I think that was the last from my side. Yeah, indeed. I will give the floor back to Stefan.
Yes, Charlotte, thank you very much. Well, please stay, Charlotte. And also I would like to ask the other presenters to turn on their cameras and unmute themselves so we can answer the few questions we have in the chat. First of all, thank you all for your presentations again. Very interesting, very clear. Yeah, we had a question for you, Charlotte, but I think you already answered it. How long does it take to get a stage 1 application approved?
But as I mentioned, it can go very fast if you are an SME, if you are in line with the de minimis regulation, and if you have well described what your innovation is about, then it can go quite fast. We just send you an approval letter and you can proceed. So let's say between 1 and 5 days.
Good. Then a question for you, Jafar. What is the lowest concentration of pesticides you can measure?
Well, the pesticides that we are actually sending to the field, it will be below the EU regulation, so it will be below 0.1 microgram per liter. We have, for example, pentazone. Now we are measuring at 0.07 microgram per liter, and we are working on actually reducing it even more. So our target is to go to 0.01 microgram per liter.
Okay, then a next question also for you, Jafar.
Yes.
Will the validation test that you're doing be used as part of the environmental technology verification for your technology?
We actually mainly will focus on the customers. I don't believe so. No, if I understood the question correctly.
Okay. Thank you.
Yeah.
Then a question for you, Ruth. Once successful testing has been achieved, are you able to introduce companies to water companies in England and Wales as well?
Yeah, absolutely. We have contacts in England, Wales, Northern Ireland and Ireland, so we can put people in contact across the UK. As AJ mentioned in his presentation, at the Scottish sites, if that's where you're testing, you have the capability of bringing people from those different water utilities or companies up to come and visit and test and see your technology in action. So yeah, we can put people in contact with them.
Thank you. Then another question for you, Charlotte. A question from, I think, a Belgian company. If we are a Belgian company, do we need to test in Belgium, or can we choose the test facility?
Of course, everybody is free to test, to choose its own test facility. Of course, you need to choose a test facility which suits best for your technology. And it's a transnational project, so we are even very happy if you are happy to travel to another country to have it tested. So no, it's all up to you where you want to test, and we will just guide you through that.
Thank you. Then another question for you, Ruth, and I think it's also related to the question I posed to you before. And that is, are you able to help companies to find out how much need there is in the UK for their technology, and what other technology options the water companies are considering for a particular problem?
Yeah, we don't necessarily have that expertise, but we can tap into, again, our networks. For instance, one of our associated partners is Scottish Enterprise, so they can help provide that kind of advice. And we also work quite closely with the Hydronation Water Innovation Service, who again can also provide that support to Scottish companies. And like I said, we do have a wide network, so we can help to at least find that information for the companies if necessary.
Okay, then I think for now we answered all the questions which were posed in the chat function. So maybe you can go to the next slide, Farah. Because of course, if you have other questions about the presentation today, about the project, about the application process, you can contact us via different channels. And what we will also do, we will send you a link to the recording of this webinar. And I see now in the chat function a new question, or at least yes, I think that's not really a question, but more a possible collaboration, and we can also answer that after this webinar. So I think now. Yep.
Sorry, Stefan, it's Erik who asked what is the lowest concentration of pesticides that can be measured? I think it's a question for IPM. Or was it handled?
Yeah, it was already handled.
Okay.
So I think for now, yeah, this was it. And what I just said, we will send you a link to all of you. And so thank you all. Thank you for the presenters. Thank you for your presentations. And thank you for listening to us. And I would say have a nice day, and we will speak to each other. Thank you very much.
Thank you. Bye.
Yeah.
Bye-bye.